Hello friends, welcome to this first technical lecture on mineral processing. So unless otherwise explicitly stated, these lectures will largely pertain to the theoretical course, that is MTPE01, Mineral Processing and Metallurgical Analysis. If any lecture is dedicated for the lab or the practical aspect, it will be explicitly stated at the very outset. So in this lecture, which is the first technical lecture of the mineral processing course, we will be trying to understand what a mineral is. So largely, I'll be using pen and paper approach to help you understand the concepts that we are dealing with in a given lecture. Rarely, I might also be switching to slides if and when necessary. Now, in order to communicate in this manner, or in order to help you visualize what I'm writing, I'm using some sort of a electronic board which is similar to writing on a glass. So that could be one of the reasons why at times my handwriting not be as legible. So whenever it is not totally understandable, then I will try to rewrite whatever I've written in the paper. If not, you might have to make some effort to understand or decipher what is being written on the paper. So yeah, that is something that you have to do. Now let us first, in order to get into the aspect or to learn about the mineral processing, in order to do that in a more convincing manner, let us first understand what a mineral is. So what we mean by mineral. So we come across this word mineral in different contexts in our day-to-day life as well. One of the contexts in which the term mineral is used is in the context of food. I don't know if you have recently come across any ad for a nutritious drink, energy drink, or any fruit products. In order to help us understand, or in order to showcase that their product consists of all the chemicals that are necessary for our body, or for a healthy body or healthy functioning of a body, they would mention that this product comprises of vitamins and minerals. So I don't know if you have come across an ad for, say, a drink or an energy drink, or the powdered form of a nutritious shake, then in those cases they would use this word mineral in order to showcase that their product comprises of all the components that are necessary for the healthy functioning of our body. So one of the contexts in which the mineral or the term mineral is used is in the context of food, particularly to denote the nutrients that are necessary for the healthy functioning of our body. So all that they mean is, in this context, is, so our body, for an healthy functioning, it needs some ions, it needs some chemical ions, and these chemical ions, for example potassium ion and sodium ion, these are necessary for our neural functions, and these ions are being provided by this product that they are selling, and which is an edible product. And in this context, in order to encompass these ions that are present in the product and which are edible to us and which are necessary for the functioning of our body, again these are ions, and these are largely in the marginal quantities, and in order to showcase, or in order to let us understand that these ions which are necessary for the healthy functioning of our body are present in their product, they use the term minerals. So often you would hear this combination of terms, that is vitamins and minerals are present in this product. And in the same context of nutrition, you could also observe that, I don't know, days before, when you want to buy a water from a shop, you would go, usually you refer to it as mineral water. So even in that context, it means that whatever ions that are necessary for our functioning, whatever ions that are necessary to help us be active, those ions are present in that particular product. And in order to refer to those ions as a category, the seller or even the vendor, they use the term mineral. The other term, or the other context wherein we would often hear the term mineral, is when we are talking about resources, or when you are talking about on an industrial scale. So the next stage, or a next context, or a next setting wherein we would observe this term mineral is when we are largely talking about the resources that are present in a given region. So these resources are the possibility of extracting or exploiting these resources for our benefit. In this context, we will be using the term mineral. So ideally, when you have a considerable amount of resources in a given region, for our benefit, we would establish an industry there and we will try to exploit these resources for our benefit. So this largely stems from purely an economical perspective, from an economic perspective. So you need to establish an industry there to exploit the resources, and this can only be possible if there is an economic benefit to us. So it also benefits us in other manner, but basically when we need to establish an industry or we need to talk about mineral in an industrial scale, then there needs to be an economic benefit to us, in addition to other benefits as well, which comes from directly from the minerals. But largely in the context of resources, only we talk about mineral if there is any economic benefit to us, and this is largely in an industrial scale. So this setting, even though this setting of food, it deals with interpersonal nutritions or interpersonal value. It has some, this in the term mineral in the context of food has some interpersonal value or a personal value to us. In case of the setting wherein we talk largely of minerals as a resource, here it's not about the personal value, but it's the value of the region, it's the value of the community. So it serves greater than a given person, but to a larger community or to a nation as well. So in this context, the term mineral is used only when it serves our purpose in an economical manner. So it gives us some economical substantiation to its presence. So minerals in a larger setting, which goes beyond our personal benefit to the benefit of a community or to an entire nation, this mineral, the term is used only when it has some economic significance. So in the previous setting, it was associated with a single person and his needs and his or her needs, and in the second setting it serves the need for the it goes beyond the needs of few, and it needs to have an economic significance to refer to a resource as minerals. So when we talk about exploiting a mineral, then it means that we need to extract it or we need to mine it out of its resource, or from the place where it is present we need to mine it out or we need to extract it. So generally the minerals, even in this context of the industries or even in the context wherein there is an economic significance, the minerals are referred to as a material with economic significance that are present in the earth crust. So unlike the context or settings of nutrition wherein the minerals are added by an industry or added by a producer, in case of the industrial context or in the case of the context of a resource, the minerals are present in the earth. So they are naturally occurring, they are present on the surface of the earth. Now such a material with some economic significance that can be extracted out of the earth is what we refer to as minerals in the second context of industrial level or industrial scale or in an economic setting. Now the way to extract such a naturally occurring substance that is of economic significance is through mining. So we need to establish mines in order to exploit these resources that are naturally occurring and that are of some economic benefit to us. And this is where we get the name mineral. So since we need to establish on a larger scale mines in order to use these minerals, we call these substances that are extracted through mines as minerals. So the term minerals means, so this is rather a old Latin term that was coined in 14th century. So it was largely associated with this scale of a larger industrial scale that is of economic significance to many, and it means according to this it means that the term mineral according to this definition means that a naturally occurring substance that is found on the surface of the earth that needs to be extracted for our benefit, and this should be of some economic significance, and in order to extract that we use mines, and that's the reason we refer to it as minerals. So minerals, it literally means out of mines, something that is taken out of mines. So in this context, or if we use such a definition, then coal, petroleum, and at times even water can be categorized as minerals. So these materials or these category of materials, they have some economic significance, and they are extracted out of the earth and its surface and a little bit beneath the surface, or particularly you can say it is extracted from the earth crust. It is of economic importance, and it is largely extracted or it is largely mined out on an industrial scale, and therefore these can be referred to as, in addition to all the other minerals that you might be familiar with, in addition to all these, we refer to, in addition to those which you might be familiar with, these coal, petroleum and water are in this context, in the context of resources, in the context of a material with economic significance that is present in the surface of the earth. When I say surface of the earth, I mean the earth crust. So you know that when you take the whole earth on a scale, and if you consider just the crust of it, even though it is of some meter thickness, it still can be referred to as surface, given that the rest of these spheres or rest of the region beneath the surface of the earth are, the length of them is quite large. So since the crust is relatively, the thickness of it is relatively small, we can still refer to the earth crust as the surface of the earth. Now, in this context of an industrial economic significance, a material that can be mined out, so in this context, coal, petroleum and even water can be referred to as minerals, and this is a 14th century definition. Now, the other context wherein we should or we would hear about the term minerals is like in our context, a purely technical one. So we as metallurgical engineers or material scientists, we look into these minerals from a purely technical standpoint. So when technicality is involved, it is necessary for us to distinguish minerals from wide range of materials that are present in the surface of the earth. So of course these minerals are naturally occurring, so they are present in the earth crust, and now we are going to deal with it in a technical perspective, so we need to distinguish it based on some of its features, and that features that distinguishes the mineral from rest of the materials that are present on the earth crust is what we use to define minerals. So whenever technically you would want to, if you want to define minerals, it is largely based on its characterizing features. So we use these characterizing features to distinguish minerals from the rest of the materials or substances that are present in the earth crust, and these characteristic features generally is adapted as the definition of minerals in a technical sense. So we consider different settings. One is the setting of food or nutrition, the other is a setting of resources or in an industrial scale that is of economic benefit to all. The other is purely this technical setting wherein we will be studying minerals, about minerals, how to work with them, how to enrich them, and how to get meaningful products out of them. So in this context, the definition of minerals are nothing but the distinguishing features that separates them from the wide range of materials that are present in the earth crust. Now, what are these characterizing features? So one of these features is similar to the one or the feature that we used in the economic setting or in the industrial setting. That is, even in the technical context, mineral is a material or a substance that is naturally occurring. So minerals are, one distinguishing features of the minerals are they are naturally occurring and they are present in the surface of the earth or earth crust. So they are not, to have a negative connotation, they are not synthetic, meaning they are not man-made. Irrespective of the time it is present in the surface of the earth, even say for instance, man built something, he created a chemical product and he left on the surface of the earth for say 10,000 or 20,000 years, it will not change into mineral. The minerals are something that are, or minerals are a category of materials that are naturally occurring. So naturally occurring in the sense that they are formed through natural phenomena. So it is not a laboratory synthesized process, or it not a process, or it is not formed out of a process that involves a human interaction. Rather, these are formed through natural phenomena and they are naturally occurring substance on the surface of the earth. Secondly, these minerals, they do not include to put it in a crude terms, dead animals and plants. So this is a very crude way of representing or describing the characteristic features of minerals. So what essentially this means is that these dead animals need not be, say for instance, a year or two old, but even if these dead animals are a part of a substance that is present on the earth crust and they have been dead for say millions of years, then those will not form the part of minerals in a technical definition. So what we mean by that is, when we take the way coal and petroleum are being formed, it essentially involves the decomposition and decay of the extinct animals and plants, or the plants and animals that have died off millions of years before. So in this context, if the technical definition of minerals, if it does not involve, so this does not involve dead animals and plants, then it means that in a technical context, coal and petroleum will not be referred to as minerals. So even though in an economical standpoint, coal and petroleum are referred to as minerals because it is something that is mined out or extracted out on an industrial level and it is of economic significance. So even though in those settings, coal and petroleum are referred to as minerals, in technical setting, when we want to study the minerals exclusively, then when we consider its characterizing features or distinguishing features, one of the distinguishing features is that it should not involve dead animals or plants. Then in that case, because of these distinguishing features, we cannot in a technical setting, so we cannot in a setting wherein we are considering or we are about to study a mineral as a category of substance that are distinguished from others, we cannot include in such a technical setting or in a professional setting like ours, coal and petroleum. So generally, one of the distinguishing features is minerals, even though they are naturally occurring, and even though dead animals and plants, they are form of a part of our nature, and the death is part of the nature. Despite all this, we do not include them in a technical sense, or we do not categorize them as mineral in a technical sense. And this particular distinguishing feature, it rules out coal and petroleum. Now, if we do not include dead animals and plants, then largely the material that we are referred to or we will be dealing with are inorganic in nature. Meaning, one of the essential components of these materials would not be carbon. So essentially, what we have done is, we are now in the process of distinguishing mineral from all the rest of the material that are present in the earth crust. And one of the condition is it should be naturally occurring. The second condition is it should not involve dead animals or plants. So if we impose this particular condition, that not involving dead animals or plants, then largely the material that we are dealing with can be referred to as inorganic substances, meaning carbon doesn't play much role in it. So carbon is not a critical or an essential component of these materials, largely because we have categorized or we have defined or we are considering a technical setting wherein we are not including the dead animals and plants or organic materials or classifying the organic materials as minerals. So therefore, largely in a technical setting, one of the characterizing features or distinguishing features of minerals is that it should be an inorganic substance. Now, in addition to that, mineral should have a definite chemical composition. A definite chemical composition. So what we essentially have is minerals are substances that are one inorganic in nature and the other it has a definite chemical composition. So the chemical composition can be defined by us. By studying the mineral, it is possible for us to analyze what are the chemical presence in them, and these chemicals are present in definite proportion. So if you combine these two, then we can combine, if you combine these two, it ultimately leads to one characterizing feature, that is the minerals are inorganic compounds. because the compounds, it has a definite chemical composition to it, and inorganic as it does not involve any carbon, or it does not largely involve any carbon. So in addition to the other characterizing features, that is, it should be naturally occurring, it should not involve dead animals or plants. The other distinguishing features of mineral is that minerals are ideally inorganic compounds that are present in the earth crust. We refer to them as inorganic compounds because they do not essentially have a huge amount of carbon, or they do not, the carbon does not play a critical role, and compounds because it has a definite chemical composition. Now, one aspect of this chemical composition, or referring to minerals as an inorganic compound, we need to understand that even though the chemical composition of definite, it is well defined, it is also not a constant one. It is also not a fixed one. So even though the chemical composition is definite, even though we are able to identify or study a given mineral and realize what are the components that are present in them, what are the elements that are present in them, and what proportion it is present, even though all this is possible for us to look into, analyze and understand, we must note that even though it is definite, it is not fixed. So what I mean by that is, when we consider an inorganic compound, it is easy for us to split the inorganic compound into a combination of a metal ion section and a non-metal ion section. Say for instance, if I am considering SiO2, so this part will be the section that is corresponding to the metal, and O2 will be the section that is pertaining to the non-metal section. So whatever compound that we are considering can be split into a metal section. So again, these definitions are rather crude, and these are for our understanding. So we can consider the compound, the inorganic compound that are ultimately present on the Earth's crust, and which we refer to them as minerals. They comprise of two sections. They have a definite chemical composition, they have a definite chemical formula. Despite these chemical formula, we can just categorize them. The chemical formula, based on the chemical formula, we can categorize them as a metal component and a non-metal component. Like we see here, SiO2, it has a metal component, that is Si, and O2, which is a non-metal component, O2. Now, overall the mineral, that means it comprises of a metal component and a non-metal component. Now, in this metal component, or in this section wherein largely the metal is involved, in a mineral it is not necessary that we just have only one metal ion in them. It is possible for us to have more than one metal ion in them. So there are several examples for it. So it is important for us to understand the minerals are not always comprised of one metal ion and one non-metal ion. So there can be numerous metal ions that can be present. So it can be M1, M2, M3, and so on and so forth. There can be numerous metal ions that can be present. And similarly, it is also possible, even though largely there are only one non-metal ion that is present, even though it is also possible for us to have one or two non-metal ions that are present. So if you consider sulfate, if you consider other combinations of a non-metal and oxygen, so these are possible wherein more than one non-metal ion is present, and in addition to that, the proportion in which these non-metals are present might vary. So what are we getting at is, even though the chemical compound, or even though the chemical composition of a mineral is fixed, the chemical composition is definite, meaning we can describe a given mineral based on a given chemical formula. It is not fixed. So it can be, for instance, M1O2, or it can also be M1, M2, O2. So even this will be a mineral, and this will also be a mineral. So instead of this, we can have M1, M3, SO4. So this can also be a mineral. So what we mean by that is, even though each of these have a well-defined chemical formula, a well-defined chemical composition, we need to note that these are not fixed. So the metal part of it, it might vary, and so does the non-metal part of it. So we might have oxide, we might have calcite, we might have sulfate, and all those things are possible largely because even though individually each mineral has a definite chemical composition, the overall, when you look at the different minerals, it is not fixed. So it is important, or one distinguishing factor is that the minerals are inorganic compounds with a definite chemical composition. So a given mineral will have a chemical composition of, say, M1O2. However, it does not mean that all the minerals should be of this particular composition of one metal and one non-metal. It does not mean that the other mineral can be M1, M2O2, meaning there can be two metals that are involved, two metal ions that are involved in combination to one non-metal. It is also possible that three metal ions are involved in combination to one non-metal ions. So ideally, the bottom line here is the minerals, it doesn't have to be, or a single representation cannot be offered for the chemical composition of the mineral. Even though each mineral, it has its definite chemical composition, it does not follow that these composition can be represented by a single formula. These different composition of the different minerals do not follow a single formula, so it is not fixed. So individually, each mineral, they have a definite composition, but when you come across different minerals, this composition might vary, and the way these compositions are distributed, they might also vary. So they have definite chemical composition, but across the different minerals, they are not fixed. Now, the other rather more a corollary of this observation, the corollary of this different composition that comprises, or that brings about a mineral, is that depending on the chemical composition or the chemical configuration of a mineral, the properties of the mineral will vary. So the property that we observe of a mineral is reflective of its chemical composition. Even though, say for instance, two minerals have a same larger overall formulae, meaning, say for instance, if a mineral has this sort of a formulae, so it has M1, M2 and O4, and another mineral has M1, M3, O4. So as when you compare these two minerals, say mineral 1 and mineral 2, largely these two minerals have 2 metal ions and 4 non-metal ions. So this is just a crude example. So you have 2 metal ions and 4 non-metal ions. Both these minerals have this similarity across them. However, they have fixed formula, meaning mineral 1 we have M1 and M2. In mineral 2 we have M1 and M3. So this difference in one of the metal ion will bring about considerable change in the properties of the minerals. So this is one of the distinguishing feature of the minerals, that is, even though they have a definite composition, even though it is not a fixed one, the components that are present in a mineral influences or ultimately influence the properties of that mineral. So if we compare two minerals of more or less the same configuration, minerals which can be rather categorized as having a similar formulae, just a single change in one of its components, single change in one of its composition, in one of the element that is present, particularly metal ion, as we consider the metal ion in this case, can significantly change its property. So let us see one example for it. For this I need to use as just a single slide. So I will use a single slide and show you how change in one particular element in more or less similar chemical composition would change the property of a mineral. So for that we will just use a slide. So I believe you are able to see this slide here. So this slide shows two different minerals, and each of these minerals have definite chemical composition. So one mineral, iodide, it is comprises of sodium, aluminium, silicon and oxygen. So it has one sodium atom, one aluminium atom, 2 silicon atom and 6 oxygen ions. And here on the other end we have spodumene, which comprises of lithium, 1 aluminium, 2 silicon and 6 oxygen ions. So these are the definite chemical composition of these minerals. So when you compare these two chemical compositions, the sodium ion in iodide is replaced by lithium ion in pseudomine. And this change, or replacing sodium with lithium ion, so replacing sodium ion in iodide with lithium ion in pseudomine, as you can see, apart from other properties, the color that is associated with this mineral is significantly changes. For instance, the iodide is of green in appearance, whereas pseudomine, it gives a pinkish shade to it. So just by replacing one ion in the chemical configuration of a given mineral, there is a significant change in the properties, even though there might be change in other properties as well. One that is clearly visible to us is the change in its color, the change in the way we see it. In case of iodide, which comprises of the sodium ion, the rest of the composition is the same, we have a green appearance. However, in case of pseudomine, wherein the sodium ion is replaced by lithium ion, we have rather a pinkish shade to it. So this is what we mean by minerals having a fixed chemical composition, or rather a definite chemical composition that can be defined by these formulae. The overall representation is not fixed. The overall composition is not fixed. One can just replace one ion with another ion. So across the minerals, if you consider just one mineral, the chemical composition of it is fixed. However, when we move or consider a wide range of minerals, when we consider more than one minerals, then even though it may have similar formulae, even though the representation of it might be similar, here we have either 4 metal ions and 6 non-metal ions. In both these cases, however, in iodide, the sodium ion is replaced by lithium ion, and it is reflective of its physical appearance. So the replacement of one ion, it shows that the physical appearance, or it influences the physical appearance. So even though for each individual mineral, the chemical composition is fixed, across the minerals it is not fixed. Across the minerals it's not fixed, and for individual mineral it is definite. So it can be defined. Across the minerals it's not fixed, and depending on the ions that are present in the definite chemical composition, depending on the ions that constitute the minerals, the properties of the minerals vary. So this is one of the characterizing features of the minerals, distinguishing features of the minerals when compared to other substances that are found on the earth crust. So they have a well-defined chemical composition that can be represented by a formulae like that. Even though two minerals might have similar formulae, it does not mean that they have similar ions present in them. So here we have iodide and pseudomine. These have similar formulae, but the sodium in iodide is replaced by lithium in pseudomine. This difference is reflected in the visual appearance that each of these minerals render. So one is in green, the other is comes with a pink shade. Now let us go back to our collectively discussing the other characterizing features or distinguishing features of the minerals. So now, so far what we have seen is minerals are a naturally occurring substance that are present on the surface of the earth or earth crust. The other is they do not have or include any product that comes from dead animals or plants, be it say few years before or millions of years before. Minerals in a technical setting, or the definition that we are interested in, it does not involve dead animals and plants. And secondly, since that it does not involve any dead animals and plants, and since it means that we are talking about an inorganic substance, and minerals also have a definite chemical composition to it, then we can say minerals are inorganic compounds. And we saw that even though these inorganic compounds, they may have similar formulae, it doesn't mean all the ions that are present within a given mineral are the same. So what I mean by that is, for a given mineral, the chemical composition is well defined, and it is associated with certain metal ions and certain non-metal ions. The other mineral might have similar formulae, but it has its own characteristic metal ions and non-metal ions. So that means every mineral, irrespective of its composition, has a well-defined concentration. But if you compare one with other, they are not fixed. Now, the final feature that distinguishes a mineral from the other substances that are present on the surface of the earth is that minerals exhibit a long range, regular arrangement of its fundamental entity. So what I mean by fundamental entity is, if you consider an element, a pure element, its fundamental entity is atom. And since we are considering a compound, largely an inorganic compound, it is possible that its fundamental entity would be an ion. Now, at times, minerals are also, these inorganic compounds are also available in the earth crust as a pure element. So, in that case, the fundamental entity would again be an atom. So, what we mean is that depending on how this mineral is present, if it is present in the form of an element, then the fundamental entity is ion, and if it is present in the form of a compound, then the fundamental entity, or rather, if the mineral is present in the form of an element, the fundamental entity that constitutes the whole material will be atom. If the mineral is present in the earth crust in the form of a compound, then the fundamental entity will be an ion. Now, these atoms or ion, these fundamental entities in a mineral are arranged in a regular order. They are arranged in a regular order over a very large range. So, we have regular arrangement of these fundamental entities that constitute a mineral over a very long range. So, this is one of the distinguishing features of the minerals. When compared to other substances that are present on the earth crust, in minerals, these fundamental entities, they can be atoms, they can be ions, in some cases they can also be molecules. These are present, they are arranged in a regular fashion over a very large or very long range. So let us try to understand this particular concept here. I believe many of you are, or this could be the introduction to the arrangement of atoms to many of you, and therefore I would like to spend some time on unpacking what it means to be long range regular arrangement of fundamental entities. So like I said, one term that you can largely ignore or that varies with the system is the fundamental entities. So in this particular statement, one term that varies with the mineral that we are considering is this fundamental entity. So this fundamental entity, like I said, for pure elements it will be atoms, for inorganic compounds it can be ions, or in some other context it can also be molecules. So this is the only term that is varying. Apart from that, irrespective of a mineral you consider, there would be a long range and a regular arrangement of the atoms or the fundamental entity. So you have two non-varying factors that distinguishes a mineral. So one varying factor is the fundamental entity. It can be atoms, ions, or molecules, but the non-varying factor that distinguishes a mineral from all the other substances is these two features, that is long range and regular arrangement. So first let's understand what long range means in this context. So what do we mean by the term long range? Because the term long range, it does not quantify anything. Just in this statement alone, it does not say what do you mean by long range, how much is this long range. So let us first try to understand what a long range is. Now, when we talk about, or when we talk in terms of atoms or in terms of ions as well, and when we consider an ion and its neighbors, so they are largely, we are largely dealing with in the length scale of 10 to the power minus 10 meters. So when we are talking about, so this is meter, and 10 to the power minus 10 meters is the range we are talking about when we are considering an atom and its neighbors. So for instance, when we talk about atoms and its neighbors being arranged like this, so the length scale that we are largely dealing with is 10 to the power minus 10 meters. So this is, for an instance, the length scale that we are dealing with. Now, when we want to have a long range, the long range usually deals with 10 to the power minus 6 meters. So within atoms, so interatomic relations between the atoms. So this is interatomic relations between the atoms, that is like the interatomic positions between the atom, interatomic interaction between the atoms. So all these are in the range of 10 to the power minus 10 meters. However, when we want to consider long range, it is generally in the range of 10 to the power minus 6 meters. So we can say something as long range if it is extended up to 10 to the power 4 times. So what we mean by that is, supposing for example, if I see an arrangement like this in an atom, and this is in the range of 10 to the power minus 10 meters. And now if this is extended over the space in such a way that the same is observed in 10 to the power minus 6 meters, the similar arrangement is observed over 10 to the power minus 6 meters, then we can say that this arrangement is a long range regular arrangement. So we can say an arrangement is regular and it's long range, or in its long range when it is the times that you observe is 10 to the power 4 times what is arranged in locally. So when you consider the local arrangement of the atoms, it is just 10 to the power minus 10 meters, and if you keep on extending it, when you reach 10 to the power minus 6 meters, only then we can refer to it as long range. Now, instead of talking of say atoms, let us consider a simple geographical setting. Say for instance, you live in a place wherein the houses are arranged like this. Now, the houses are arranged like this, and say this is a plot of land, and these are individual houses, 1, 2, and so on and so forth. The smaller squares within the plot of land are houses. They are arranged in this manner. Now, these houses are arranged in such a way that they cover over a wind scale of 1 kilometers. Okay. Now, if similar setting, similar arrangement of houses are found for 10 to the power 4 kilometers, only then we can say these houses are arranged regularly over a long range. So let me repeat, you have a definite arrangement of the houses. You live somewhere here, and you have a definite arrangement of the houses, and these houses are arranged for your neighbors, and your house, it is arranged for 1 kilometer. And now we can call such an arrangement long range when it extends to 10 to the power 4 kilometers. Only if it is extending to 10 to the power 4 kilometers, meaning when it is extended to 10,000 kilometers, when you have similar arrangement of the houses for 10,000 kilometers, only then we can refer to it as long range regular arrangement. If not, it will not be referred to it as, we do not refer to it as long range regular arrangement, and this long range regular arrangement is what gives us the crystalline structure. So when we say in minerals, the fundamental entities, ions, atoms, molecules, they are arranged in a regular manner that extends over a very long range, or that extends over long range, then essentially we are saying that minerals are crystalline in nature. So what it means to be having a regular arrangement in a long range is that it should not be arranged regularly in a local region. It should not be just within 1 kilometer or so, or just 10 to the power minus 10 meter. It should extend to 10 to the power 4 times. This particular arrangement should extend over a very long range, and that very long range is something close to 10 to the power 4 times. So, like we saw in this example, you and your house and a neighborhood, even though locally it might be some sort of a regular arrangement, it can only be referred to as long range when this arrangement, the similar arrangement, it extends to 10,000 kilometers. So whatever neighbor you see, whatever the neighborhood you see, if the similar pattern or similar arrangement is extended to, instead of just your neighborhood, just 1 kilometer, if it is extended to say 10,000 kilometers, only then we could say this regular arrangement is long range. And only when you have long range regular arrangement of atoms or ions, then the structure would be, we refer to that structure as crystalline structure. So a mineral, it needs to satisfy all these distinguishing features. One is, it needs to be naturally occurring. The other is, it needs to be inorganic in nature. It should not include dead animals and plants. So it should be inorganic in nature with definite chemical composition. But these chemical composition, they need not be fixed. So largely what we are dealing with is in the context of minerals, we are dealing with inorganic compounds. And now these inorganic compounds, depending on the chemical composition, their properties would vary. And finally, the minerals are of crystalline structure. So what we mean by that is the fundamental entity that constitute a mineral, they have a regular arrangement, and this regular arrangement, they extend over a very long range. So as we see here, it at least extends over 10 to the power 4 times of its local arrangements. So in terms of atoms, the local arrangement are 10 to the power minus 10 meters, and this local regular arrangement should extend till 10 to the power 6 or minus 6 meters. So there should be the regular arrangement that extends over 10 to the power 4 times. And the same we have seen in this example. If we have a neighborhood setup that is just for 1 kilometer, it should be extended to 10 to the power 4 kilometers, meaning 10,000 kilometers, this neighborhood should be extended. Only then we can refer to it as the long range regular arrangement of the atoms. So what other features, or how else these regular arrangement can be defined more precisely, is what we will be seeing in the next lecture. So with this overview, or rather with this consideration of the distinguishing features that separates minerals from rest of the materials that are present in the earth crust, we will wind this lecture up. In the next lecture, we will consider what we essentially mean by the regular arrangement. So far our discussion just revolved around long range. We want to see what we mean by long range, and in the next lecture we will consider what we mean by regular arrangement. So the takeaway point is, long range is not that is locally confined. It should extend at least 10 to the power 4 times the local arrangement. Only then we will be able to understand, or we can categorize that particular arrangement as the long range. So we will see ourselves in the next lecture, wherein we will be considering the term regular arrangement more closely. Goodbye.